All right, this is a pitch for patching declarative partial updates and out of order streaming. Wait, I want to see faces too, not just my slides. Okay, it's good there. Okay, so let's start with the big picture. It's big, but hopefully well compressed and optimized for good LCP. So this is how we see the status quo, and this is the big picture. One can call it motivation for why we're working on this, because why are we working on this now? Because it's been like requests for this kind of stuff for a long time, but we see a lot of people building app-like experiences in the web, like chat widgets, persistent audio, gestures, micro interactions, having multiple fragments. And people, in order to develop those app-like experiences, they choose normally an SPA architecture with updating the same document multiple times rather than MPA or switching between documents, one document to another. Just keeping persistent audio in MPA is really difficult, and all the rest as well. Now, when people go to SPA architecture, they also go to low level and JavaScript integration. Like a lot of things are integrated on the JavaScript level with low level APIs. And this leads to too much or a lot of userland code. And I'm sure we see that a lot as performance engineers. We see junk, we see big download size, we see bugs that come from just having too much code that's not properly tested, UX glitches from having to write everything so many times, maintenance burden from a lot of code, and cut corners around accessibility from writing the same button many, many times with JavaScript, etc. So how we deal with this on a high level, or the strategy for how we want to deal with this, is we want to take some of the building blocks that people need in order to write SPA and introduce them as foundations to the platform so that people don't have to have this much userland stuff. And we want to allow multiple levels of integration into them, meaning people can integrate them into existing frameworks at a more complicated level as a power tool for optimization, and people can use them directly with the platform without having to have a bunch of a big JavaScript for that. The SPA foundation we're currently looking at is a composition. We'll explain more about them, partial updates, and routing. In routing, we won't touch on this one. So it's about composition and partial updates. So I would say that the web platform in its MPA document state is very much tuned for paging, where you have multiple pages that are separate from each other and you switch between them. While modern apps, and specifically mobile web apps, actually often built around having one big page with scrolling, where the pages are parts embedded within the page. Now, we introduced iframes for this about 25 years ago, I think, but iframes are very heavy-handed. You can't style an iframe together with the embedding page. Should have had a slide about this. You can't query select in an iframe. All the analytics script need to know about the iframe. It's like something about it is very heavy-handed, and a lot of developers don't use it unless it's like really for specific purposes. So a single page app is often composed of multiple fragments that would otherwise be documents. The other part is partial updates. So an SPA is usually comprised of initial load that is big and includes good HTML for getting it perform well, and also for what's called SEO that says that it's better. And usually you have a big initial load, and then afterwards you get smaller JavaScript-based updates. This duality is kind of complicated, and frameworks try to abstract it by introducing what we call server-side rendering and iteration. You use the same code to render the component tree to HTML, and then you use the same code to update it based on the new state. This is complicated. It's different across frameworks. The code that does that is very, very carefully crafted and usually tied to clouds, to particular clouds, providers and hosting providers, etc. And of course, it's not criticism to whoever producing something like that. It was solving a real problem and in a very clever and good way, but we wanted to see if the web platform can help there as well. So enter patching. So patching, the concept is streaming HTML content into existing DOM. That's what the patch is in a nutshell. So the way it helps with composition is, first of all, we allow out-of-order streaming. So if we can stream HTML content in an existing DOM, we can stream the whole HTML out of order. We can have a shell of the HTML, and later on, while we stream the HTML, we can inject content into it. A very simple example of this is you have a select box very high in the DOM, and loading the content from it, let's say a list of countries or a list of users, takes a while. So you can have the select there and then stream, and then when the content for it is ready, you can stream it into the select box as option elements. And yeah, so the other thing about composition is that the content we inject can either be inline or it can be from a different URL. It's also a very old requested feature of client-side include that had a few times being added and removed from the platform. And this is an attempt to solve it more holistically rather than have just a one-off client-side include feature, but like tie it to a bigger picture. This is a prior art of how out-of-order streaming works in React. You have in React something called render to readable stream, where you can take a React tree and you can have suspense boundaries. And in this case, the spinner would be rendered into HTML. And when the gallery is ready, if you see in the middle, we await something. Once that's ready, React will stream out as an inline script element that updates the spinner by targeting the comment node before and comment node after and finding the space between them and changing it to an actual gallery. That's how that works. It's a kind of user space code people need to deal with. So the way we're proposing to solve this is starting from HTML and from a template attribute called patch4. 4 is an ID ref for now. And patch means that whatever is streamed into the template is going to be rerouted to the target, which in this case is whatever has an ID called gallery. So in this case, you would see loading, and when the template starts streaming, loading would be replaced progressively with whatever is in the template. The other bit of it is patch source. So if we pick the gallery, we can also stream to it from a URL. It's fetched with course and everything, and then streamed into the target. This is very similar to client-side include, except it follows the semantic of patches. It's a verb that you know where it's going, you know where it's coming from, you have ways to update it, you have ways to abort it, all kind of things, to intercept it. And the other use case is, oh, I didn't update the content here, it's just the title. So partial updates, what happens after you load the document and try to make updates for it. So this is how we deal with partial updates after the document has been loaded. We add a function called, in this case, patch self. It might be just called patch, the container node. That patch function creates a writable stream, and we can pipe anything to it. We can pipe anything stringable would be parsed as HTML, and any bytes would be decoded using the HTML, the document's character set, and then piped through HTML. And on top of the things, we have something we call interleaved patching, where you can have another writable stream that takes an HTML stream and just takes those template patch 4 snippets from it. So, for example, that response can be the whole document. I can stream this, for example. This is a document that has a title, has a gallery, and then has patches or change zone. I can stream this into patch all, and only the changes would apply, the title and the gallery. So, or I can just stream the updates if that's what I want. I can just stream this kind of response. So this feels like a bit of a waste because we stream a lot of bytes that we're going to treat as comments, basically. The nice thing about it is that the author doesn't have to think about whether this is a soft or hard navigation. They just need to think about their content and which part of it can change. And then it would just work for either a regular navigation or a patch all. And this is optional. People can either have the extra optimization of having a separate response or just reuse the same response if it's good enough. And it's pretty cheap bytes because it just goes through the HTML parser and doesn't run any scripts, etc. The other thing that makes this more useful than just doing this yourself is that it contains reflection. You can get the current patch for an element and have a promise when it's finished. You have a patch event that you can intercept a patch and make it go through sanitation or whatever it is you want. Excuse me. If you so choose, or just know that the patch failed. This is a nice one, I think. You can have a CSS selector that tells you that an element is in the midst of patching, so you can make spinners work without having to deal with JavaScript for this. You can decide that you don't want the incremental loading, so you just make a patching element invisible while it's being patched. All kinds of things you can do with this thing. The other thing currently in the proposal is to patch into a range. For example, you can select a range that's between 2 IDs and stream into that, or after an ID or before a given ID, etc. We are already in conversation with security about this. First of all, one concern was that these patches could introduce invalid HTML, and the parser actually knows how to deal with this. The parser has something called fragment processing that's used for inner HTML. So we use the same fragment processor, and like we know where we're parsing into. So if you're parsing style, it will be parsed as text, and will go straight into the style sheet rather than adding elements to a style. And a remote patch from patch source is coarse and has to go to the same CSP as script. We do not inject scripts that this patches. For example, if you put text into an existing script element with a nonce, you can do that, but the script will not be run, so it doesn't do much. And if you have trusted types, it turns off streaming. So you just buffer everything and send the string to trusted types for sanitation, until a point in the future where trusted types can buffer themselves in some way. Oh, I forgot. Just again. Forgot I was going to demo. Just a second. So I'm sorry. Okay, so here patching is not supported because it's only enabled in Canary. And let me share the other window. Can you see this?
Yep.
So here we have an internal list. And here the list is being streamed from a worker. And it can also stream from a server. And I can change the filter as it goes along without loading the document. If I look at the code for this, I basically create a stream for the list with patch self. Can you see my DevTools? Yeah.
Yep.
So I create a stream with patch self. I get the filter. I start a worker and pass it the stream, or I get the fetch and get the stream from the response, and it's patched directly into the list. And you see it turn from yellow to green. That's because it had a patching thing on it. If I look at the list, and it has a patching superclass that makes it yellow. So while the list is loaded, it's going to look like this. And also we have the loading thing that appears throughout this time. Another thing, another demo here is the live stream. This is basically a continuous stream. It's just a single request. And I'm just getting a stream URL, and streaming it into patch all. And I keep getting more and more patches and changes. And the response here looks like bytes. Okay. But what this response does is basically more and more template elements with given ideas that change the output. That dispatch this S1, S2, and S3 with a new output. So I can basically have streaming HTML without having to have more and more fetches for it. And let me share it. And that's it. Questions?
There's one question on the chat.
Yeah.
Just 1 sec. Let me stop the recording and discuss. But